Hi everyone, welcome back. In this video, we will see example 4 for couple and moment calculation. Check the link in the description for basics of couple and moment calculation and other examples. Example 4. ABCD is the weightless rod under the action of forces P, Q, S and T as shown. Calculate the resultant and mark the same in direction with respect to the end A of the rod. ABCD is a rod, PQST is the force with an angle of 45 degree, 30 degree, 30 degree and 60 degree respectively. This is the rules. So first we have to resolve the forces. For resolving the forces, angle it should be always with nearest x-axis. Then we have to resolve the forces into horizontal and vertical components. For horizontal components we have to give cos. For vertical components we have to give sine. For reverse and downwards direction we have to give minus. For upward and forward direction we have to give positive. Now let's resolve the forces. Sigma h, sum of all horizontal components, minus 10 cos 45 minus 4 cos 30 plus 8 cos 30 plus 12 cos 60. Solving this we will get the result of 2.393 Newton. Now sum of all vertical components, 10 sin 45 minus 4 sin 30 minus 8 sin 30 plus 12 sin 60, which gives the value 11.463 Newton. Resultant is equal to root of sigma h square plus sigma v square. By substituting the value we get the value 11.71 Newton. Theta equal to tan inverse of sigma v by sigma h. We'll get the value of theta. So sigma v and sigma h both are in positive direction. Sigma v which indicates y-axis, sigma h which indicates the x-axis. Resultant is in between these two axes and it is at the angle of 78.2 degree. Now if we'll draw this resultant in the rod ABCD, we'll get like this. So this resultant is here like this at an angle of 78.2, which is at a distance of x from A. The perpendicular distance from the point A is z. Now to calculate the moment, so for calculating the moment we should not consider this sign. We have to consider only whether the forces rotating the rod in clockwise or counterclockwise direction. We have to consider only the rotation direction, not this sign. So if we take moment about A, these two forces, they don't have any rotation, so it is 0. And this 4 sin 30, it rotates the rod in clockwise direction, so we have to take negative. And this 4 sin 30 is at a distance of 1 meter from point A. And this 4 cos 30, it won't rotate the rod, so we can neglect this one. And similarly this 8 cos 30 and 12 cos 30, this won't affect the rotation of the rod, so we can neglect. And this 8 sin 30, it also rotates the rod in clockwise direction, so we have to take in negative direction, minus 8 sin 30, which is at a distance of 2 meter. This 8 sin 30 and perpendicular distance is 2 meter. And this 12 sin 60, it rotates the rod in counterclockwise direction, so we have to take in positive. And this 12 sin 60 is at a distance of 3 meter from point A. By solving this we get 21.176 Newton meter as the sum of all moments. By applying Varignon's theorem, sum of all moment is equal to the moment of the resultant. So this horizontal distance and this resultant, when we multiply this equals sigma ma. So r into z is equal to sigma ma. We know the value of r, we know the value of sigma ma. By substituting this we'll get the value of Z. Z equal to 1.808 meter. Now, so this forms one triangle. This is 90 degree and sine 78.2 is equal to Z by X, opposite side by hypotenuse side. By this we can calculate the value of X. X is equal to 1.847 meter. So now this resultant is acting at an angle of 78.2 degree and is acting at a distance of 1.847 meter from point A. And alternate method is, so instead of calculating these two steps, directly we can calculate for sigma V as sigma V here and sigma H here. So sigma V, this perpendicular distance, we can take this as X. Sigma MA is equal to sigma V into X, resultant force into distance is equal to sum of the moment. So sigma V into X is equal to sigma MA. So from this we can calculate X. This is the alternate method.